Today we are going to be looking at another way to graph a linear function. We have been working on graphing linear functions, making a t-chart. This is another way, another tool in your tool belt. It's a pretty simple way. In order to make a linear function, you only need 2 points. You can connect 2 points together and draw the line. That's all you need, and that's what we're going to be doing today. Intercepts are important in graphs because they tell us some important bits of information. In this example right here, we have a diver who explored the ocean floor 120 feet below the surface and then ascended at the rate of 30 feet per minute. The graph shows the diver's elevation below sea level during the ascent. Now, if you remember the 4-quadrant grids, we have the first quadrant here, the second quadrant, the third quadrant, and the fourth quadrant. If you notice this graph right here, the x's are positive, which is this line, and the y's are negative, which is this line. So we're actually down here in the fourth quadrant. If you look over here at the Y-intercept, you see that it is on negative 120. Now that number is important because that tells us the depth that the diver was to begin with. If we were to write an ordered pair for this, x would be 0 and the y would be negative 120. Notice what the x is for the y-intercept. That's going to be important here in just a little bit. If we look up here at the x-intercept, it intercepts at 0. So that order pair would be 0. And if you look down, oh, I'm sorry. The x, down here for the x, is 4. So the x is 4, and it's 0 at the y. Flip that, I apologize. And that 4 is important too, because the 4 tells us the number of minutes it took for the diver to ascend. So with the y-intercept, we know the depth that he began, and with the x-intercept, we know how many seconds or how many minutes it took him to ascend. Notice with the order pairs, the y-intercept, x is 0. For the x-intercept, y is 0. So it makes sense that if we want to create 2 order pairs and we plug in 0 for y and 0 for x, that we can find the x and y intercepts. Here's another example. Trish is running a 200-meter run in 25 seconds. And if you look at the graph, the x and the y-intercept again give us some important bits of information. The y-intercept right here is at 200 meters. So this told us the distance she had left to run at the beginning of the race. Here at the x-intercept, we see that intercepting at 25. That gives us the number of seconds it took her to cross the finish line, because 0 down here would be the finish line. So the x and y intercepts are important because they give us the information we need, and it's an easy way to graph if we can find the x and y intercepts. Again, this order pair up here would be 0, 200. So for the y-intercept, the x is 0. Down here, the order pair would be 25, 0. So for the x-intercept, y is 0. So what we're going to do is we're just going to plug in zeros to either the x or the y and solve for the other to create 2 order pairs to graph with. Let's see how this works mathematically. Now this particular equation is in what we call standard form. When the equation is written in standard form, and we can look up here and know that this is a linear equation by what we learned in yesterday's lesson. If it's in standard form, it becomes very easy. So to find the x-intercept, we want the y to be 0. Well, if we plug in 0 to y in this equation, you know that any number times 0 is 0, so this part of the equation basically goes away. So if we want the x-intercept, the y goes away, and we have a one-step equation. 3x equals 12. So x equals 4. So what is that order pair? Well, the x was 4. And the y was the 0 that we were plugging in. So we have one order pair now. If we can get one more order pair, we can graph this function. That was finding the x-intercept. Now to find the y-intercept, we do exactly the same thing, except we want to fill in 0 for x. Because remember, with the order pair, the x is going to be 0. Well, in this equation, if we fill in 0 for x, 3 times 0 is 0, that part of the equation goes away. So the only thing you're left with is negative 2y equals 12, which makes y equal to negative 6. If y is equal to negative 6, we know that's part of the order pair, and we plugged in 0 for x. We now have two order pairs, and we would be able to graph that and create a linear function just using the x and y intercepts. On your notes, here's another example that we're going to do. Again, to find the x-intercept, we want to plug in 0 to y. If we plug into 0 to y, that part of the equation goes away because any number times 0 is 0. You're left with the one-step equation. And of course, x equals 4. So our order pair that we created was 4, 0. To do the other intercept, we're going to fill in 0 for x. Well, if you fill in 0 for x, of course, that part of the equation basically goes away. You're left with negative 4y equals 8. Y equals negative 2. And of course, x was 0. So now you have two order pairs, and you're able to graph those two order pairs and create a line. Here is another example. It's not on your notes, but again, we'll just practice real quickly. To find the x-intercept, we want the y to go away. We plug in 0 for y. When we plug in 0 for y, that leaves us a one-step equation. X is positive 4, sorry. X is equal to a positive 4, and of course y was 0, so that's our first order pair. We graph it there. To find the y-intercept, we're going to plug in 0 to x, which makes this part of the equation go away. So y is just a one-step equation. Y equals negative 3, so our order pair is 0, negative 3. Really easy when it's written in standard form. Now, if it's written in another format, it works the same way, but you may have a two-step equation instead of a simple one-step equation. We're going to look at an example of this. Fishing lake, sorry, this is in the way. Let me see if I can move this thing over. Oh, yes. A fishing lake was stocked with 300 bass, that is a kind of fish. Each year, the population decreased by 25. The population of bass in the lake after X number of years is represented by the function f of x equals 300 minus 25x. And of course, each number appears significant. We began with 300 fish, and then each year it decreased by 25, so that's how we got our equation. Remember that this is written in function notation. In function notation, we have f of x, which is the same as our y. So if you think about it written in standard notation instead of function notation, we're just going to replace that f of x of y, and we're going to do the same thing. To find the x-intercept, we want y to equal 0. So we're going to plug in 0 to the equation right here. So that would be 0 equals the rest of the equation. I don't know why I wrote 35 right there. 25x minus 25x. So this time it just takes us two steps to solve for x. We want to get x by itself, so first we have to move the 300 to the other side by subtracting 300 on both sides. When we do that, we have negative 300 equals a negative 25x. Of course, now we're going to divide both sides by negative 25, and we're going to find that x equals 12. So what's our order pair? Well, x equals 12, and we substituted 0 in for y. Now we're going to get the y-intercept. To get the y-intercept, we want the x to be 0. Well, this, if you look up here, if we substitute 0 in for x, this part of the equation goes away, and all you're left with is y equals 300. We have our second order pair, 0, 300. And so when we graph it, we go over here to 0, 300. That's the number of fish that the lake began with. We go to 12, 0. That is where by year 12, there were 0 fish left in the lake. So we were able to graph that function by just figuring out the X and Y intercepts. An easier way sometimes to graph, and it also gives us the important information that we need. There we go. Get my clicker to work. And that concludes our lesson. I hope you have learned how to graph a linear function using the X and Y intercepts.